So we've been talking a lot about lines, parallel lines, transversals, and finding angles. And so now we're kind of go and look at the sort of reverse process. So we know that if a transversal cuts through parallel lines, then certain angles have certain relationships. But now we're going to be looking at the, again, the reverse of all those statements. And we're going to be seeing if two angles have a certain relationship, then the lines must be parallel. So this first one is called the parallel postulate. And it says that if given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the line. So if I'm given a line and a point, here's my line, and here is my point, big point. We can draw an infinite amount of lines through that point. So I can draw it like this, and we can see it intersects the other line. Well, I can draw it like this, and again another intersection. I can draw it like this so that it's very, very narrow, and eventually it will intersect, like a million miles in that direction. However, there is only one line that I can draw through that point so that these two lines are parallel. These little marks mean that they're parallel. And we can prove this, but we don't need to. Just when you're given a postulate, you just say, "Great, thank you. I acknowledge this as truth," and move on. But yeah, again, a million, billion, trillion different lines, an infinite amount of lines we can draw through this point, but only one is going to be parallel to this other line. Then we have this. If two lines are in a plane and it's cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So here we can see angles 1 and 5 are congruent. Well, that must mean that lines N and M are parallel. Previously, when we looked at this, we said if lines M and N are parallel, corresponding angles, such as angles 1 and 5, are congruent. Now we're just going backwards, and we're saying, hey, if these two angles are congruent, the lines must be parallel. And we can see that about any of these other corresponding angles. Then we also have this, that if two lines in a plane are cut by a transversal so that a pair of alternate interior angles are congruent, then the two lines are parallel. Could probably copy that. Whatever. Let's draw some lines. So here we go, some lines cut by a transversal. I know nothing about these lines. Do they look parallel? Yeah, but I can't. Unless it explicitly says that these two lines are parallel, I can't assume that they are, and I have to pretend that they're not. And if you look at SAT or ACT, even GRE problems, what they will do is actually give you a pair of lines like this and that look parallel, but mathematically aren't. And they'll say picture not drawn to scale to try and trick you. So please, please, please do not fall into that trap. If it does not say that these are parallel, we don't know. However, if we see that a pair of alternate exterior angles are congruent, so that would be like this and this. So we can say this is line M, this is line N, this is angle 1, this is angle 2. So we can say that if angle 1 is congruent to angle 2, then M is parallel to N. And this is going to be very, very important because we're going to need to prove that lines are parallel, and we're going to use this fact that the alternate exterior angles are congruent to say that they're parallel. So once we know that they're parallel, once we show that these alternate exterior angles are congruent, then we can say, all right, these are parallel, let's get down to business. We just can't say, hey, these lines look like they're parallel, so they must be. It doesn't work that way. Okay, here we have another one saying, if two lines in a plane are cut by a transversal, say a pair of consecutive interior angles is supplementary, then the lines are parallel. Well, we know that these two are going to be consecutive interior angles. We'll call that angle 1 and 2, this line M and this line N. And we know that if lines M and N are parallel, these two angles are going to be supplementary. So if we switch this around, we can say, hey, if angle 1 plus angle 2 equals 180 degrees, then M is parallel to N. Before we said if M is parallel to N, then angle 1 plus angle 2 is 180 degrees. Now we're switching the order, and that still is correct, and that still holds true. Here we have another one. So if two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. So much like our alternate exterior angles, here I have line M, line N, my transversal. A pair of alternate interior angles are congruent. So we'll say that's 1 and 2. So if angle 1 is congruent to angle 2, then, getting ahead of myself, then M is parallel to N. Pointing out the fact that just like the other ones before, if I said if M is parallel to N, then angle 1 equals angle 2 because they are alternate interior angles. Now I'm saying, well, if angle 1 and angle 2, alternate interior angles, are congruent, then M must be parallel to N. And in a plane, if two lanes are perpendicular to the same line, then they are parallel. So if two lines, just like this, are both perpendicular, look at this. These are corresponding angles. Well, wait a minute. We already know that if corresponding angles are congruent, lines must be parallel. So that means then M is parallel to N. This is just an extension of that idea in saying that, well, if they're both perpendicular, again, they both have the same measure of 90 degrees, then these lines are going to be parallel, which is a really cool fact, and that's going to help us out later on. All right, proofs. We need to look at a proof now. And so we're given that R is parallel to S. We can tell by the little triangles. And angle 5 is congruent to angle 6. So I'm just going to mark that on the picture. I want to prove that L is parallel to M. So L is parallel to M. Well, if nothing else, we can always have, so there is we're going to have our statements and our reasons. And we're going to say R is parallel to S, and that's given. Number 2, we're going to say that angle 5 is congruent to angle 6, and that is given. All right, so number 3, this is where we start looking. What do we want to show? We want to show that L is parallel to M. Think about what 5 and 6 are. Think about the other relationships we have here. Also, we know that R and S are parallel. So how can I use that to my benefit? Well, if I know that R and S are both parallel, use line L as a transversal. And then we can see, well, wait a minute. That means that angle 4 and angle 5 are supplementary. So that means that angle 4 and angle 5 are supplementary. because they're consecutive interior angles. So this is the consecutive interior angles theorem, saying that if I have two parallel lines in a transversal, consecutive interior angles are going to be supplementary. Likewise, I can say that what can I say? Well, if I look here, I have this line going through L and M. I know that 5 is equal to 6. So what if I say, if 5 and 4 are supplementary, then 4 and 6 must be supplementary. Wait a minute, why can I say that? Well, I can say that because angle 5 is congruent to angle 6. So me saying that angle 4 and angle 5 are supplementary is actually the same thing as saying angle 4 and angle 6 are supplementary. This is through substitution. See how I just replaced the 5 with the 6? I wrote the exact same thing in my sloppy handwriting, and I just replaced the 5 with the 6 because I know that angle 5 is congruent to angle 6. Well, wait a minute. If angle 4 and angle 6 are supplementary, that must mean that L is parallel to M, and that's because consecutive interior angles are supplementary, making those lines parallel. So I proved what I wanted to prove. I'm done. That's it. Now that's just one way to do it, but you kind of want to leapfrog around. If you look at the initial picture, I mean, you almost want to look and say, well, yeah, 5 and 6 are the same. Look at them. Just look at them. And you even might want to think, oh, well, they look like alternate interior angles or some sort of angles. But unfortunately, they're not. And we can't make that jump without already knowing L and M are parallel. So by us saying, well, if I look at R and S as parallel lines and line L as a transversal, then 5 and 4 must be supplementary. And since 5 is the same exact measure as angle 6, 4 and 6 must be supplementary. 4 and 6 are also consecutive interior angles. So if they are supplementary, those two lines, L and M, are parallel. So it's a nice little approach for this proof. We're going to be getting a lot more practice with proofs, but we can also have, not proofs, some algebraic maneuvers. So here in the figure, BG, so BG, right there, that's going to bisect angle ABH. Bisect, that means cut in half. Two equal halves, right? It's not like if I tell you I'm going to let you have half of my slice of pie and I give myself a much larger half than yours. Those aren't halves. In mathematics, a half is equal area, so equal measure. So this ABH, if it's cut in half, well, look, I already know 1/2. This portion here is 45 degrees. So this portion must also be 45 degrees. Wait a minute, would that make a right angle? It would, but this is not drawn to scale. Tricky, tricky. This is very popular in SAT type questions. So be very, very careful. Don't say, oh, I must be wrong because that should be a right angle. That should be 90 degrees. It is. It just doesn't look like it. Okay, so we want to determine which lines, if any, are parallel. Well, this angle here is 65 degrees. So let's just find all the angles. We know that DF and AB are not parallel because consecutive interior angles must be supplementary. Well, 90 plus 65 is not 180. But what about down here? Well, let's take a look. So if this is 65, this is going to be 115. And if this is 45, this is 65, triangles add up to 180 degrees. So together these make 30. So that's 50 degrees. If that's 50, this is 130. And let's take a look here. So 130 plus 70 is 200. 200 plus 115 is 315. So 315 from 360, this is a quadrilateral. Quadrilaterals add up to 360 degrees. So that 360 degrees minus 315, sorry, 380 degrees. I said 60 because 380 minus 315 is 65. Ooh, look at that. 65 and 65 corresponding angles are congruent. So that means that this line DF is parallel to line GH because of corresponding angles. So with a problem like this, we didn't need to write out a formal proof, but we need to write out these measures. We needed to go through one by one and show these actual angles. So be very, very careful and take what you know and go from there. Find out everything else. You know a straight line adds up to 180. Maybe you don't know a triangle adds up to 180 or a quadrilateral adds up to 360. In this class, we're going to be going over that later. So I don't require you to know it now, but it can help. And you can figure this out other ways too. But find what you don't know from what you do know. And just like this, we want to find a measure of x so that RSU and measure RSU so that M and N are parallel. Well, I'm given these two angles. They're corresponding angles. If M and N are parallel, these two are going to be congruent. So that means that 8x plus 4 must be equal to 9x minus 11. If those lines are parallel, this is true. So if I show that these two are equal to each other, then M and N must be parallel. So what would be the value of x here? Well, if I subtract 8x from both sides and add 11 to both sides, I get 15 is equal to x. So x is equal to 15. Well, what's RSU? That would be 8 times 15 plus 4. 8 times 15 is 120, I think. Let me just double check, right? So, yep, 120. So if I add 4, I get that measure of angle, RSU is equal to 124. And just a little hint or a little word, whenever we have this measure, we don't need to write a degree symbol. Now if I just said this, angle RSU, that should be 124 degrees. But if I have the measure, this is just no units attached to it. So that's really helpful. All right, so that's it. Take your knowledge of angles and parallel lines and transversals and use that to prove lines are parallel and find the measures of angles.